Hi, I'm Chris Collins from the University of Reading and I'm a professor in environmental chemistry. So at this site we're doing some investigations into water quality, in particular turbidity. So that's the colour or cloudiness of the water. And that's one of the key indicators of water quality. And the particular research we're doing at the University of Reading is we're using turbidity as an indicator of pesticide loading as pesticides get washed off the fields associated with soil particles. So an increase in turbidity would potentially mean an increase in the amount of pesticide entering the water body, and that's of great interest to water companies.
At the University of Manchester, what we're doing, we're taking the turbidity measurements that Chris has described, and at the present moment they're expensive to produce these measurements because there's a limited number of instrumentation and there's only small numbers to be produced. So the sensors that are used at the moment are very high quality, very high accuracy. If you turn that problem around and say, okay, well, let's start looking at very low cost sensors. In the case of what we're looking at here, the sensors are actually originally designed for dishwashers, the white goods, so obviously very, very cheap and designed to actually look at the effluent coming out of the dishwasher. Obviously for the sorts of duties that we're looking at turbidity within river water, we want a lot lower measurements and very good accuracy and repeatability. So what we're doing there is we're using a large number of these sensors in an Internet of Things, a lot of devices talking to each other. By doing that, we can get some internal calibration, if you like, where one sensor is actually supporting the measurements of another one to increase their accuracy. So in that way, even the sensors themselves may not be the highest accuracy. By working together, we get a map of where the turbidity is sort of spreading throughout the water course. And then get some increased accuracy as well. Obviously, as the longer term goals are progressed within the project, we look at higher quality sensors. Again, very low cost, but different ways of designing them to get the higher sensitivities that we require for this type of duty.